Let's continue on the topic of derivative. Today we're going to talk about chain rule. It's for the composition of functions, and we want to find the derivative of two functions composed with each other. So let's say if you have the capital function f, and it's constructed based on the two functions f and g, when f and g are both simple functions, then what would be the derivative? The derivative would be, let's assume f of g of x is, we have the function f of g of x, and we want to find out what is the derivative of f of g of x. You take the derivative of the outside function operated on the inside function and multiply it by the derivative of the inside function. It may look confusing and this, until you see an example, but this is generally the idea that if you have, let's say, f of g of x, and they ask you to find the derivative with respect to d of x, you can think about this and say, okay, I'm going to call this inside function star. So what I have is d over dx of f of star. What can I do instead of taking the derivative with respect to x is I can take the derivative with respect to star of f of star and then multiply it by the derivative of star with respect to d of x. And what happens is these two will cancel out. And this is not the ID, this is not proof or anything. This is just generally what you see is what comes out. And what is this star? This star is simply the g function. So what you have is f prime at star multiplied by g prime x. Okay, so here f prime at star g prime x. Okay, this is just basically a hint of how the proof goes, but not really the proof. Okay, and we can generate similar idea by assuming that one of the function is a power function. So if you have a function composed with an exponent n, what you can do is use the power rule, drag down the exponent, subtract 1 from the exponent, multiply by the derivative of the inside from the chain rule, multiply by g prime. This is basically power rule combined with the chain rule. It involves a function to some power. Again, I will show you examples of each, but this is just basically the rules that we want to apply. Chain rule would be derivative of the outside multiplied by the derivative of inside, and derivative of outside operate on the inside function, then multiply by the inside function derivative. And the power rule is apply the power rule, multiply by the derivative of the inside. And if you look at the inside derivative, it never has any power in either case. Okay. So here's a simple example. What you have is a sine function operating on an x squared function. So this is an inside function g. This is an outside function f. And here's an inside function g. I'm going to avoid writing f and g because there is already an f. So here, if I want to take the derivative, so we want to find out what is f prime x in all these questions. What do I do is, to find the f prime, you say the derivative of the outside operating on the x squared still, multiply by the inside derivative. That is it. Derivative of the outside function operating on the x squared still, multiply by the inside derivative. What is the derivative of sine? Simply cosine. The x squared there, multiply by derivative of x squared, 2x. This is the derivative. There is no prime involved anymore. So you can rearrange them and say, okay, 2x cosine x squared if you want. Same thing. Okay, how about this one? Sine x squared. There are two ways to do it. Write it as sine x times sine x and use product rule. Or you can use the power rule and say, okay, I'll drag down the exponent. So 2, keep the inside function, sine x, to the power 2 minus 1, which is simply 1. By chain rule, it says multiply by the derivative of inside. So multiply it by the sine x derivative. And what you get is 2 sine x still are there. This is an exponent. And the derivative of sine x is cosine x. This is the derivative. Try to use product rule, you should end up with the same result. Okay, how about this one? Tangent sine x to the power 1/3. So first look at this and say, okay, this is the inside function to some power 1/3. So what I will do is I will drag down the exponent 1/3. This inside function stays there, tangent sine x. I haven't changed anything about it. Subtract 1 from the exponent, 1/3 minus 1. So 1/3 minus 1. You can do it without writing it. So 1/3 minus 1 is negative 2/3. So I can write negative 2/3. Multiply by, chain rule now applies. It says multiply by the derivative of the inside. The derivative of the inside is tangent sine x derivative. Let me use bracket. Too many parentheses, it's confusing. Okay. You're not done because you haven't calculated this derivative yet. So how do we calculate the derivative? This first part has no derivative, stays there. Tangent sine x to the power negative 2/3. This is still there. Multiply by. How is the derivative of tangent sine x? Now you see you have an inside function sine x to an outside function tangent. I'm going to write the chain rule. Derivative of the outside operating on the inside. Multiply by the derivative of the inside by chain rule. Sine x derivative. What is the derivative of tangent? So this first part is still the same, times derivative of tangent. It would be secant squared operating on sine still. It's not secant squared x, it's secant squared of whatever that input was. Times derivative of sine, cosine x. This is still, let me write this as well, 1/3 tangent sine x to the power negative 2/3. There's no need for simplifying, but this is the result. This is the result of the derivative. Okay, this was a power rule combined with a chain rule. You had to apply both of them. How about this one? We have square root of x plus x over 1 plus x. First, rewrite this as power because you don't know how to take the derivative of the square root unless it's written as power 1/2. This is not the derivative. I'm just rewriting the function. So what would be the derivative? Derivative would be simply drag down the exponent, subtract 1 from the exponent. The input does not change. 1 plus x to the power 1/2 minus 1. That is negative 1/2. Multiply by the inside derivative. What is the inside derivative? Inside is x over 1 plus x derivative. And this is power rule. Drag down the exponent, subtract 1 from the exponent, and multiply by inside derivative. Okay, the first part is still the same, 1/2 x over 1 plus x to the power negative 1/2. This always stays the same at this point on, because there is no derivative involved for this term. For the other one, you have x divided by 1 plus x and you want to take the derivative. What type of derivative you need to do, what type of operation you need to do is you need to use the quotient rule. Derivative of the numerator multiplied by the denominator, 1 plus x, minus the numerator times derivative of the denominator, 1 plus x derivative. All divided by denominator squared, 1 plus x squared. Again, the first part is still the same, 1/2 x divided by 1 plus x to the power negative 1/2. I can try to simplify it, but that's not my goal at this point. Derivative of x is, here, let me write the derivatives above them. Derivative of x is 1. Derivative of 1 plus x, this is again 1. Derivative of 1 is 0. Derivative of x is 1. So what you have is 1 times 1 plus x is 1 plus x minus x times 1, x. And these two will cancel out. So you have 1 divided by 1 plus x squared. I'm going to erase these parts and say 1 divided by 1 plus x squared. And this is the derivative. This whole thing. This is the derivative of square root of 1 plus x over 1 plus x. Again, simplification is not the goal here. Is take the derivative, make sure there is no prime left at the end. Oh, this one, you have two functions multiply by each other. Do not jump ahead. First look to see what you see. You have t times sine of pi t. And you want to take the derivative. So what rule you apply is, first you deal with this as product rule. Derivative of the first one times the second function plus the first function times the derivative of the second. Sine pi t derivative. Okay, derivative of t is simply 1. So you have 1 times sine pi t plus t times, now what is the derivative of sine pi t? Now you have an outside function operating on an inside function. So here I'll say it is the derivative of the outside acting on pi t multiply by pi t derivative. Chain rule. Derivative of the outside multiplied by the inside function derivative. Okay, so you still have 1 times sine pi t is sine pi t plus t times sine derivative is cosine pi t still there, multiply by, what is the pi t derivative? If you had 3t and I ask you what is the derivative, 3 is a constant, doesn't really matter. What would be the derivative of 1? Derivative of t is simply 1, so you'll get 3 times 1, which is 3. If this was pi is like 3, it's constant. Pi times 1, pi. The derivative of pi t is simply pi. Again, pi is not a variable, it's a constant. You can always keep it fixed. Okay. This is the derivative of t times sine pi t. Do not jump ahead to the chain rule. Try to apply the rules in order. First you need to apply the product rule, then after that chain rule is necessary. Okay, how about this one? Tangent x times cosine x. You cannot start from x times cosine x. When you need to start is from the outside. So what do? I'm not going to take the derivative of tangent. I'm going to assume that this is an inside function to an outside function tangent. So I will apply the chain rule and say f prime x would be derivative of the outside affecting on the inside, cosine x, multiply by derivative of the inside, x times cosine x derivative, chain rule. Derivative of tangent, secant squared, applying on x times cosine x still, multiply by the derivative of this x times cosine x. Here there is no outside or inside function, there is a product between these two. I have to apply the product rule. Derivative of the first times the second plus the first times the derivative of the second. So you will have secant squared x times cosine x times derivative of x is 1 cosine x plus x times derivative of cosine negative sine x. Okay. Again, there is no need for simplifying. Everything is multiplication, and just rearrange the signs and put them in order if you want. Okay, there is no prime left. This is the derivative of tangent x cosine x. If you compare it to the last example, this one, in the last example, t sine pi t, there is product first, so you apply the product rule first. Here you see the chain rule first, because the outside function is affecting first, then you deal with the inside. How about x plus 1 over x to the power 5? You can write this 5 times and apply the product rule 5 times, but why would I do that if I know the power rule? So f prime x would be, drag down the exponent, 5, multiplied by the same function. There is no derivative here for the function. subtract 1 from the exponent, 5 minus 1, 4, multiply by. Now here is where I multiply the inside derivative, 1 plus x derivative. Again, 5x plus 1 over x to the power of 4 is fixed. There is no derivative involved. What is the derivative of x? Simply 1. Derivative of 1 over x. I need to figure out what is the derivative of 1 over x. So here, let me write derivative of 1 over x separately, so I don't have to rewrite all these stuff again. Derivative of 1 over x, you can write as x to the power negative 1 and take the derivative. Or you can use the quotient rule. Either way is correct. This is x to the power 1. I can move it to the numerator and make it x to the negative 1. Drag down the exponent, negative 1. Subtract 1 from the exponent, x to the negative 2, which is the same as negative 1 divided by x squared. So it's plus negative 1 over x. This is the answer. Okay, you can always try to write the derivative separately, then combine the result, but make sure that you do it correctly. Okay, here's one more. Actually, two more. Yeah, these ones look maybe more complicated and need more work, but it's exactly the same procedure. First, you write this in terms of power so you can take the derivative. 1 plus sine t divided by 1 plus cosine 2t to the power 1/2. Now I can take the derivative. Do not jump ahead to take the derivative. First, figure out what the question is asking, since for all these examples, I want the derivative. That's why I jump ahead to the derivative. And you rewrite the function in a way that you can apply those rules. F prime x would be, drag down the exponent, 1/2, apply the power rule. 1 plus sine t divided by 1 plus cosine 2t to the power 1/2 minus 1 is simply negative 1/2. And by chain rule, I have to multiply it by the inside derivative. Again, if you're multiplying the inside derivative, you notice that there is no power or anything involved. It's exactly the inside function, just the derivative of it. There is no 1/2 or negative 1/2 as an exponent. Okay, so at this point, this yellow part, this highlighted section, I'm not going to rewrite it because it's too many steps if we keep rewriting it. So I'm going to call it star. So I will say this equals star times whatever that is. At the end, you can rewrite it. Okay, so let's figure out what is the derivative of 1 plus sine x over 1 plus sine t over 1 plus cosine 2t. Since this is a fraction, I have to use quotient rule. Quotient rule says denominator squared 1 plus cosine 2t squared, and multiply by derivative of numerator here. 1 plus sine t derivative, multiply by the denominator, 1 plus cosine 2t cosine 2t minus the numerator, 1 plus sine t times derivative of the denominator, 1 plus cosine 2t derivative. Right, so here at this point, what I can do is I can calculate each of these two separately and replace it back into the formula, because I don't want to keep rewriting this over and over. So I'm going to calculate 1 plus sine t derivative. After I did that, I will replace it here, number 1. And number 2 is I will calculate this derivative. These are the only two terms that have derivative that I need to calculate. So first I will calculate that, then I will calculate 1 plus cosine 2t derivative. Otherwise, I have to continuously write these stuff over and over. Okay, what is 1 plus sine t derivative? Derivative of 1 is simply 0. Derivative of sine t, cosine t. So this number 1 simply turns out to be cosine t. So it would be star times cosine t times 1 plus cosine 2t minus 1 plus sine t times whatever the number 2 derivative is. So here number 2 is would be 1 plus cosine 2t derivative would be derivative of 1 is 0 plus derivative of cosine 2t. You have to apply the chain rule. You have an inside function and an outside function. Derivative of cosine applying to 2t multiplied by 2t derivative. This is the chain rule. Cosine prime 2t is cosine prime is negative sine derivative of cosine 2t multiplied by 2t derivative, simply 2. 2 is a constant, derivative of t is simply 1. So what we get is negative 2 sine 2t. So instead of number 2, I can replace negative 2 sine 2t. So this derivative of that square root turns out to be this whole thing. Okay. You have to replace that primes with cosine t and negative 2 sine 2t. And we'll write the star back. Okay. Here's another one. This is the composition of 3 functions. But you've only learned chain rule for 2 functions. So what I'm going to do is apply the chain rule. Assume this yellow part is 1 function. So what you do is you say the derivative of the outside f prime x would be derivative of the outside tangent derivative applying to the inside function sine cosine x multiply by the derivative of the inside. Inside function is sine cosine x, and I want to take the derivative. Okay, so this yellow highlighted part is what we consider as the inside function. We have the derivative of the outside operating on the inside multiplied by the inside function's derivative. Okay, what is the derivative of tangent? This secant squared. Still applying to sine cosine x multiply by, what is the derivative of sine cosine x? Again, now here, this highlighted section, I can break it into 2 parts and say, okay, here's an inside function to an outside part, and I can take the derivative of that. What would be the derivative? It would be operate the outside function's derivative, so sine derivative operating on cosine multiply by the cosine derivative. Derivative of the outside multiplied by the derivative of inside. Derivative of outside operates on the inside function. So here you'll get secant squared sine cosine x, that's still there, multiply by sine derivative, it's cosine, you'll have cosine x, multiply by the cosine derivative is negative sine x. This is the derivative. And by the way, be careful here. Cosine of cosine x, this is not cosine squared. Do not write that. Cosine x is an input to another cosine function. It's like thinking about square root of x. They do not equal to something specific. In this case, actually, you can write this fourth root of x, but do not do this. Do not write cosine squared. It's not product. It's operating. Okay, so this is the derivative of tangent of sine of cosine x. And if you know how to take the derivative of this one, every other example would be very similar to, very easier than these 2 last examples that I did. Hopefully this is good enough, and I'm gonna stop at this point.